short video for physics. In today's episode, we are going to look at vertical intercept. By the time this video ends, you will be able to define the vertical intercept. You'll be able to find the vertical intercept on a graph, whether you do so visually, just by seeing where it crosses, or whether we have to solve for it mathematically. So with that, let's begin. The vertical intercept of a graph is the location where the line of your graph crosses the vertical axis. For those of you that may have forgotten, our vertical axis is the up and down axis, and our horizontal axis is the side to side. Math class will often call them y and x axis, but I don't like that because math class is unoriginal. They only graph y and x. We don't graph y's and x's. You will never graph y and x in physics class. We graph real life things, position, times, forces, accelerations, lots of interesting quantities that we can measure and manipulate in a lab. We graph those. And we graph them on the vertical and horizontal axes, respectively. And the vertical intercept is the location where my graph line intersects or crosses the vertical axis. It's the value for the vertical quantity when the horizontal quantity is equal to 0. X, I don't like x is equal to 0. What's the y value? Well, if it crosses nice and neat, we can see, oh, the line crosses right at the 4. So the vertical intercept would be 4, whatever units this was in. All right, there's the 4. But what happens if it doesn't cross at a nice intersection point, like this graph, where it crosses there, and is not numbered? I don't know where it is. But I look at my scale, 1, 2, 3, 4, 5. All right, these are going up by 1s. So this is somewhere between 3 and 4. So the value that you report out better be more than 3 and less than 4. I would probably look at this and say it's a little more than the halfway point. I'd probably go 3.6, 3.7. Something like that would probably be in the ballpark for a graph like that. So it might cross the line nice and neat. It might cross where we have to estimate where it falls, but what happens if I give you a graph where you can't see the vertical intercept? My graph cuts off somewhere between 10 and 11. And the line keeps going up, it's going to cross way up there. But I have no idea where it is. All right, we can solve for that. We just have to solve for it mathematically. The steps are fairly straightforward. The first thing that we need to do is find the slope of the line. Remember, to find the slope of the line, we're going to drop down and find out the rise versus the run. To find the slope, we're going to take the change in vertical divided by the change in horizontal. For this graph, my line changes by 5 units down and 2 units across. So my slope is going to be -5 divided by 2, which in my world works out to be -2.5 to be precise. That's a negative slope. Once I know the slope value, I'm going to use my slope-intercept form, the y equals mx plus b form that you might be familiar with in math class. We are going to plug in a known vertical value, a known horizontal value. For this example, I chose 10, 5 as my point. So I plug in 5 for my vertical value, 10 for my horizontal value. Slope I just found was -2.5, so I plug that in. And then b is my vertical intercept, my unknown in this algebra equation. To solve this out algebraically, multiply 10 by -2.5, which gives me -25. Then I need to move that -25 over the other side. To undo that, I add it to both sides of my equation. So 5 plus 25 in my world is 30. Therefore, my vertical intercept would be 30. I can't see where it crosses the line way up here, but I just calculated that it crosses at 30. And there you have it. We've seen in this video that the vertical intercept is the location where our graph crosses the vertical axis. We have seen that we can either look at it off the graph, read it directly. We might have to estimate it. It's fine either way. But in a case like this, where I can't see where my graph crosses the vertical axis, well, then I have to do mathematics and solve for it. Find the slope, plug it into my y equals mx plus b equation, calculate the vertical intercept. That's all for this episode. We'll see you in the next one.